I'm going to talk about Angular, look at some of its capabilities, its features. I'm going to try to present hopefully a balanced view of what's good and bad about Angular, where it applies, where it doesn't apply, why you might want to use it in certain situations, why you might not want to use it in some other situations. We'll get into looking at some Angular code, get a flavor of what it's like to deal with Angular on a daily basis, hopefully. And then if there's time at the end, we'll take some questions. And as Ken mentioned, there's going to be a panel discussion at the end of the day where hopefully we can have sort of a lively give and take about the various platforms, their pluses and minuses. So what is Angular? As the title, I think Ken put a title on this talk about the big, the bad, the API overlord, something like that. I'm calling it batteries included. It's a full-fledged framework. It's large. It's all-inclusive. It's opinionated, and it's not just a library, which is the feature of some of the other things you hear about today. Is it's a library, do what you want. This is more, here's the framework, do it our way. And what you get is, it's developed by a team led by Google. It's an open source licensed, MIT licensed, as I believe are React and Vue. So if you're comparing these three, there's not a real difference as far as licensing concern. Angular is a complete rewrite of Angular JS. There's a little bit of unfortunate naming decision going on here. So previously Angular 1.x is now known as Angular JS, and Angular 2 and forward, we're now up to Angular 7, are just known as Angular. So when you try to Google for documentation or jump into Stack Overflow and search for things for Angular, of course you get both. And you have to sort of Google for Angular and exclude Angular JS, and you'll still get a lot of overlap, so it's all pretty unhelpful as far as that goes. It's got a large community, as you saw from the graph that Ken put up. It may or may not be the best framework for you at the moment. It's got seems to have the most interest, the most activity, with React coming up quickly from behind. Angular has a lot of third-party libraries. Many of them are high quality, of course, because NPM is sort of an open thing and anybody can publish it to it. There's varying degrees of quality of libraries, but there are, if you're careful and research, you can find a lot of pretty high quality libraries. Documentation and training are pretty widely available for Angular. Again, some of it better than others. And of course, as Ken mentioned, Chariot does training for Angular. And with actually, I think I skipped a slide here. Go back. No, I didn't. All right. So with a single installation, you install Angular. That's other than having Node in the first place. That's all you really have to install, and then you can generate a full application from the command line. Angular's written in Typescript. It's usually you will develop in Typescript. You can theoretically write an Angular application in JavaScript, but nobody does it because it'd be really painful, and I wouldn't recommend trying it. And as Ken mentioned, TypeScript is a superset of ES 2015, gets transpiled to ES5 so you can actually run it in your browser. TypeScript is a statically typed language. It looks object-oriented. It has generics. If you worked with Java generics, it's kind of like that. It's kind of similar in that those generics don't actually exist at runtime. The object-oriented features of the language don't actually exist at runtime. It's all a facade to let you write object-oriented looking code in JavaScript using Java-like syntax, which is great because you can get up to speed quickly. The downside is you have to actually be aware of the differences and what it's actually transpiling to and what you can get away with and what you can't. Angular's a component-based architecture, as our React and Vue. It's the thing in SPA applications is to encapsulate your code in components. That makes it reusable. It isolates you from side effects. Helps you do use the single responsibility principle. And along those lines, it's also modular. And Angular, again, there's a little bit of a learning curve. There's two types of modules in Angular. You have ES 2015 modules, and then Angular has its own concept of modules. And for better or for worse, they don't merge the two. You actually have to work with both. And we'll see an example of that shortly. So what does Angular bring to the table? What does it provide? So it has a command line interface. I believe all three of these environments do. Angular is pretty advanced. You can use it to generate a new project. You can also use it to add features to your project after it's generated. And the latest versions of Java post, like kind of Java 5.6, I'm sorry, Angular 5.6 and forward have things called schematics where you can actually plug things into the command line interface generator. So if you have your own thing that you want to be able to have your developers generate from the command line interface, you can plug into that. And library developers are starting to use that. So you're doing an NPM install of their thing, and then all of a sudden the CLI has their functionality in it. Angular gives you a canonical project structure. So if you were thinking like, where do I put my files and how do I arrange them and how do I arrange various modules and put them all together? Well, Angular is flexible in this, but by default generates a particular structure, and generally people just follow that. The Angular CLI recently grew the ability to create an Angular library, package it and publish it as an NPM module. That was an extremely difficult thing before Angular 5, Angular 6, and now they've made it very easy. So you can just write a little bit of user interface or whatever and package that up and use it, put it in a local repo or publish it to the NPM repository and share that across multiple applications pretty easily. As Ken mentioned, I think Angular loves RxJS. Pretty much everything that could be RxJS in Angular is. It's used for things you would expect, like making HTTP calls, where you get the one-shot observables. For handling mouse clicks, I think, as Ken showed, that's a streaming observable. You can do that. You can observe the router. Just all sorts of things. Basically anything where you could possibly treat something as a stream or do something asynchronous, it's going to be an observable. So if you're going to learn Angular and do Angular development, you're going to have to come to terms with RxJS. It's a bit of a learning curve. People usually spend anywhere between a couple of weeks to a couple of months really getting comfortable with RxJS, but it's well worth it, in my opinion. Angular has server-side rendering. They call it Angular Universal. I'm not going to get into that very deeply, but if you're interested in quick first page load, maybe for enhancing SEO, if you pair it up with something on the back end that's node-based that can render your pages, you can have server-side rendering with Angular. Angular also does native mobile applications. They paired up with the native script team and worked out a really tight integration between native script and Angular. And as we'll see in a little bit, Angular is not actually tied to the DOM or web development. So you can use it to develop an iOS application, an Android application, and it's actually possible to write code where there's one application that goes to all three of those, and there's just slight differences depending on platform that get swapped in or out. I haven't tried it, but I understand that it works really well. An Angular application, when you generate it, will come with testing fully set up, both unit testing and end-to-end testing. And it's using Jasmine and Karma, and for the end-to-end testing, Protractor. The Angular framework has a handful of things that are standard, and the thing you see most often in examples and you run into most in development are components. But actually the base of all this is a thing called a directive, which you might be familiar with if you've seen Angular JS development. A directive is a class that can affect the DOM, so it gets access to the DOM. A component is a directive that has a template. There are things called pipes, and they're essentially like filters. So a common one is the date pipe. You can take a date, send it through the date pipe, and get a string out the other end that's formatted in a particular way, and they're used all over the place. And then there are services, which if you've done Spring development, you can sort of make anything a service in Spring by giving it an @service annotation. And similarly in Angular, you can call anything a service, and all you're really doing is exposing it to the dependency injector, which, by the way, is another major feature of Angular, is its dependency injection. Angular has constructor-based dependency injection. It's the only option, where in other environments you might see setter injection or property injection or constructor injection. Constructor injection is really the only option here. Angular comes with a router, so again, you're not going to be making a decision about which router library should I use. You use Angular's router, and it's tightly coupled to the rest of well, I shouldn't say tightly coupled, but works with the rest of the framework, and it's RxJS based. Angular comes with an HTTP client. Again, you could use something else, but it works. The one that's there works really well with Angular. It's RxJS based. So particularly a thing that comes up a lot is if you're getting parameters to a component from a router and you want to make an HTTP call, since the router's RxJS and the HTTP method is going to be RxJS, you can merge map over the router arguments and invoke the HTTP with the result, and it's all just one big stream. And that's pretty helpful. Angular components have HTML templates. So this is one place where it differs from React. My understanding is in React you have your JSX templates in your code. Angular's the flip of that. You have standalone templates that might have a little bit of code in them. So that's one thing you might consider when you're looking at it if you have a strong opinion about that one way or the other. By default, components in Angular have their HTML templates encapsulated with respect to the CSS. So CSS that is applied to that component's template does not bleed out into other components. Other components don't bleed into it. That can be overridden. Sometimes you need to do that. But, and it can be turned off entirely so that you just have one big style sheet for the whole application. But by default, you're encapsulated. Angular has data binding. All of these libraries have data binding, but they differ in how they do it. Angular gives you the choice of one-way binding or two-way binding. And all the React folks are going, oh no. And then if you're a fan of the Redux pattern, Redux is actually available for Angular as well. Angular has actually two forms libraries. The first one is called template-driven forms, and that's basically a form with two-way binding. So you change the value in a field on a form, it directly updates the underlying model. And then there are reactive forms, which is a little more complicated, but actually a little more useful, where the form has its own model. You set it up, it maintains its own model. You get events from the form as users interact with it. You can set it up with validators. The validators will fire as the user interacts with it, so they might fill out a field and tab to the next field, and you immediately get maybe an error message if validation failed in the first field. And you might see a submit button enable and disable as the form goes from valid to invalid. And then because it has its own model, you're not mutating the components model. And then you can ask when the user hits the submit button, you can actually ask for the form's value, and it's separate from the components model. And that's also gets pretty useful when you start doing things like Redux. And there's lots more stuff there. There's probably more features in Angular than I could possibly have time to cover today. We'll see a few more as we go along, but if you're interested, there's lots of things on the web to read. So the question that I thought maybe people would be asking here if they're evaluating whether to use one framework or the other is Angular a good fit for my development team? So Angular is a really good fit if you have greenfield development projects. The flip side of that is if you have an existing project, adding Angular to it is not very easy to do, bordering on impossible. So if you're looking to slowly enhance an application, Angular probably is not for you. For greenfield development, you're in good shape. If you develop medium to large size applications, you'll see the benefit of Angular. Modularization makes it easy to share modules across multiple applications. So if you're a team that develops more than one application and you want to share functionality, that's a really good feature of Angular. If your development team is not heavily invested in pure JavaScript, they're not JavaScript experts, maybe they're coming from back-end development, they don't want to or don't feel capable of making all the decisions about what libraries do I use, how do I put it together, what form library do I use, what HTTP client do I use, do I do it in TypeScript or JavaScript, which version of JavaScript, all of those architecture decisions, they're already made for you in Angular. And the flip side is if you do have a bunch of people who are heavily invested in JavaScript and want complete control, they're not going to get it here. And if that's what you want, you should probably look at something like React. And again, if you're doing Angular, you're going to be doing TypeScript. There's just really no way around it. And if your team is coming from a back-end object-oriented environment like Java and Spring or .NET C#, it's a really familiar environment. TypeScript makes it look object-oriented, even though it's really JavaScript at the end of the day. And that, again, is a good thing and a bad thing. It gets people up to speed quickly, but it can also fool you very easily. You can start doing things thinking that they're going to work the way they do in Java or C#, and they don't. So things like the arrow functions or and the this pointer are things to be aware of if you go this route. So what does it look like to generate an Angular application? Once you have NPM installed, you're doing an NPM install of the Angular command line interface. And then you can just do ng is the Angular CLI. You can say ng new, your project name, and you sit and wait for NPM to download the internet. And then your project is ready to go. You can go into the projects folder and type ng serve. The -o will open a browser window and open the application for you once it's started. And by default, the package.json in your generated application will include a start command. And if you do npm start, it actually runs ng serve. And here's a little bit of the project structure that I was talking about. Because it didn't all fit vertically on a slide, I've got half of it to the left and half of it to the right. But we can see you get your standard package.json, being that it's a node project, and a package lock if you used npm. There's your node modules that's eating up half of your hard drive. Here are some generated end-to-end tests, configuration file for Angular itself. And some other configuration files. There's a TypeScript lint configuration file and a TypeScript compiler configuration file. And then you've got the source directory. So from here over to this tree here is your source directory. Again, you have some configuration files. This sets up your testing. There's an overall style file for the application, which can also be SCSS. And actually, there's a minor configuration on your Angular project to switch over from CSS to SCSS. And there's also a flag to the ng generate command, which will generate it with SCSS. So some polyfills. Main.ts here is what actually bootstraps the application. And you have an index.html, which is obviously what the user loads when they first load your application. That loads up the JavaScript file that gets transpiled out of main.ts. We have some environments. These are places to put some configuration. It's kind of a weak feature of Angular. They just give you development and production, and you can hard code some stuff. So in a real world application, that's not particularly useful, except for the one flag that they put in there by default, which is production, true or false. Again, kind of minimally useful. There's an assets folder, and then the meat of your actual application is right here. So you have the app module. Again, that's an Angular module. A single component, which is your application. There's a test file for your application. It's the application's HTML template and its CSS file. So what does a component look like? The app component that gets generated is a little bit of a special case because it's the root of the application. It's a little different from all of the other components that you're going to have in your application, but most of it is the same. First thing you'll notice is a thing up here, at component. You might say, well, what is that? That looks kind of funny. That's a thing called a decorator. It's an experimental feature of TypeScript. It's destined eventually for ES, I don't know, 2017, 2018, something like that. And it's actually not a full-fledged feature of TypeScript yet. It's an experimental feature, but Angular ships with that feature turned on and uses it heavily as if it were a real primetime feature. And what this does is add metadata to the class. And again, it's kind of like an annotation in Java, but only kind of. What it actually does is add properties to the JavaScript object at runtime after it's transpiled. This thing gets transpiled into ES 2015. So the first thing it has here is a selector, and that's a unique name for the component, and that's what gets used in an HTML tag when you want this component to show up. So simply by taking that name, putting it in an HTML template in another component makes this component render in the other component's output. And it's prefixed here that the linter by default wants you to actually prefix your name with app, but fortunately that's configurable, so I changed mine to spa. And it's got a template URL right here. It points to that HTML file, and that's where the HTML template's going to be. You can also put template there and then put your HTML directly in line. That's useful for a very small component. You have 4 or 5 lines of HTML, and you want to see it right in line and don't want to have it in another file. And then it's got an array of style URLs. And again, you can, if you don't want them external, you can put in styles. That becomes an array of strings that are your inline styles. The one thing you should be aware of when you're doing this is if you're using SCCS, if you're using Sass, you can't do that inline because the preprocessor won't see it there. So if you do styles directly inline there, it's got to be CSS. And then finally, you have a class. And again, that's going to transpile to the ES5 class. You know, this is, again, as Ken mentioned, eventually going to be a prototype somewhere. Classes don't really exist. And this export here, that's an ECMAScript export. That's not a TypeScript export or an Angular export. Here's the HTML template that component was pointing to. And by the way, I switched over from the default generated application to our spa day application because the default generated application doesn't have anything interesting in it. So you can see it's mostly HTML, or actually in this case, all standard HTML. It does have some custom HTML elements in it, which is now a legal thing to do. So here you see spa welcome. So there's actually a component somewhere whose selector is spa welcome. And putting that right here makes that component render right there in that template. There's also a thing called a router outlet. And as I mentioned, Angular has its own router built in. Router outlet is where a component that is routed to will render. So a typical simple Angular application has this app component with a router outlet and then a handful of top-level components that get routed to, and they all show up right there. So typically what you wind up doing is if you have a persistent menu, some Chrome around the outside of your application that's going to be there all the time, that might show up in the app component here, and then you're just switching out the content within that Chrome into the router outlet. And then in our case, we also have that chat window that you saw in Pete's prototype there, and we render that at the bottom of the page. So this chat window winds up being persistent across the whole application because it's outside of the area that's routed to. It's in the outer app component, so it never goes away. And then when that template is rendered, it looks something like this. And if you notice, those original tags are still there. So you see the spa welcome tag there, and it's got a bunch of funny business going on here. And what this funny business is the encapsulation, the CSS encapsulation. So nodes get these attributes, and then the CSS gets post-processed to apply only to those attributes. And that's how you get your encapsulation. Vue is doing the same thing. I'm not sure what React's way of doing that is, but it's probably similar. Okay, Angular has, as we said, one-way binding, two-way binding, lots of options. So the first thing here is a simple expression binding. So inside of a template, you can take a property of the component and just render it directly, assuming that's string or something that will stringify reasonably. Just put it between double curly braces, and it'll render right there. This is an event binding, so we have a button with a click event that it's handling, and that's a method in the component. So when the button's clicked, it'll call that method. Then there's two-way binding. This is referred to as the banana in the box. There's the box, is the square bracket, and the round braces are the banana. So as with the click handler, the round braces are the event handler, which in this case is the change handler. So when somebody types into the input, the change handler fires. And then binding into the property, so taking, say, the login name property of the component and making it display in the input, that's the square braces. So that gets you your two-way binding. And then at the bottom of the page, you see one-way binding. And basically what we've taken is the bidirectional binding and broken it up into its two pieces. So this takes the login name and puts it into the input. And this says, when it changes, don't actually modify the login name property, call this method and give it the event. And that'll be, to get the value, it's event.target.value, as it would be in JavaScript. This is the app module that's generated, slightly modified for this application because we have routing. Again, we have a decorator that tells Angular, it's metadata that tells Angular it's a module. It has a declaration section, and this is where you say, I have components or directives that I'm going to provide. Provide's probably a bad word because that's used for something else. But this makes the module a factory for that component. It has an import section, and this is where we say what other modules we depend on. So anything that these modules export will now be available to everything inside of this module. And you can see I imported the browser module, which is the Angular API itself that works with the DOM. There's also a native script module. So if you're doing native development, you would replace the browser module with the native script module, and then you're doing native instead of browser. I have an app routing module, which we'll see in a minute, and that's what sets up my routing for this main component. Probably a bunch of other stuff. And then the chat window is its own module. And you can see I'm importing that because I'm going to interact with that at this level. You know, we see the tag, you previously saw the tag for app chat in the app components template, and this is what makes that chat component available, is it's exported from the chat module. Providers is where you put services that the module is going to provide. It's a really simple app, so there are none, at least not at the root level. There are other modules that have services, but there are no services here. And this is where one of the special cases comes in. If you provide a service in the app module, in the root module, it becomes available to the dependency injector across all of the child modules. which is not the case with any of the other ones. And then finally, we tell it what component to use to start up the app. So this bootstrap only shows up in the app module. It doesn't show up in any of the other modules. And then finally, again, we have our ES 2015 export. So here's our router module. Now, you can do all of this directly in the app module. We're just separating it out so it's easier to understand. And it's separate. We set up our routes, and you'll see it looks very much like routing in all the other frameworks. They all almost identical. Because basically you're trying to do exactly the same thing. So on the left is the path. What's the path that's being routed to? And in these cases here, you see parameters in the path. And then what component are we going to route to when we see that path? And at the bottom, there's a catch-all that redirects to the root path. Angular's router is pretty sophisticated. It can also do, besides routing directly to a component like this, it can do lazy loading. When you see the syntax here, that has to be a module that was in the imports. You can, and which means it's going to be loaded right away when the root application loads. There's a syntax over here where you can route to a module which will get lazily loaded and which will itself have its own router and do its own sub-routing when it's loaded. Again, we have a module decorator with the imports and exports, and then the ES 2015 export of the module. And if we go back here, you can see that we had imported that app routing module here into the app module. So that makes those routes available everywhere in the app. Okay, so Angular has a built-in HTTP client. Again, you don't have to use it. Most people will use it. It's very good. It's there. It's RxJS. It works with everything else. So I don't think I've seen anybody build an Angular application and not use Angular's router. So here's a very simple example. So this might be a service that provides all your, it's kind of common to create a service that wraps all the HTTP calls in your application, wraps the API. So here we see a method that might be in that class called getSession. This is actually out of our application where a session is the thing you're registering for a particular time slot that you saw on the application. And that session has an ID, and we want to get the session object. And the syntax here, if you're not familiar with TypeScript, that's the return type right there after the colon. So we're returning an observable of session. And here we return, HTTP is the HTTP client in this case. And we're doing a get. And we have a type here, says we're getting sessions, and then the URL. And this is an interesting case here because this is compile time only. This is a hint for the compiler and for the linter. This says, I'm going to get something back and I'm going to treat it like a session, but you have to be aware that what you're really getting back is a JSON object. So it's just an object, it's just a bag of properties. Excuse me, the prototype does not contain any methods. So it's pretty common to create these domain objects with no properties so that this just works. Because if you have say this had properties and you got one back from the HTTP call and then tried to call a method on it, the method's not going to be there. So you have to be aware of that, and if you're actually doing that sort of thing, you're going to have to map the result here to actual objects, create the objects on the fly. Again, it's sort of a pattern to not try to do that. As a matter of fact, I think, best practice is to pass an interface here. And again, interfaces don't exist at runtime either. I just wanted to mention, my timer's not working, so if you want to keep me on track. Okay. Okay. So that's one of the pitfalls here. It's great, but it's really just sort of, it's not even a type coercion. It's just you're telling the compiler, okay, at runtime, that's going to be a session. And if it isn't, what you're going to get is whatever was actually in the JSON, and then when you try to get the properties out of it, they're not going to be there if the shape is wildly different. It'll still run, you'll just get a runtime error. So the get method returns the observable. Here's a more complex example. This is actually a pretty complex example. We have a case in the application where sessions have registrants. And on that final registration page where we say, congratulations, you've registered, and here are all the participants for your session. We don't have the registrants at that point when we want to go get them. And, I'm sorry, the deal here is we want to show all the sessions with the number of participants up front. The problem is we don't have the participants and we don't have the counts. In a real world API, you probably control the back end, and you could say, well, let's just put the counts on the sessions, or let's actually put the arrays of registrations on the sessions, and then we'll just have them. But sometimes you're working with somebody else's API, and maybe it's not designed really well, or it's not designed for your use case, and you have to do some workarounds. So instead of correcting the back-end API, we chose to do almost the least efficient thing we could do. And I'll tell you why that's almost in a minute. So what we're doing here is we're getting the session, and then if you're not familiar with RxJS, we're merge mapping over we're getting an array of sessions. We're merge mapping over that array. And then the fork join says, for each item in the array, so for each session, we're going to make another HTTP call to get the registrations for that. And then we're going to map over those arrays and get the count. And I guess I could scroll right here. If I find my cursor. Yeah, I can't find my cursor. Oh, there it is. Okay. So there we go. So we're getting the length. So I say almost the least efficient thing we could do, and it's only almost because we actually used fork join here. And fork join is actually going to send out as many of those HTTP calls as it can in parallel based on how many connections are available in the browser, and then queue up the rest of them, and only when all of those are done will it go to the next function in the list of functions. So it's kind of scatter gather. So we're at least doing a little bit of parallel here. We're not going and getting each one sequentially. But it's kind of an example of the crazy and twisted things you can do with RxJS. And the other thing to point out here is we're making a whole bunch of HTTP calls here. So one to get all the sessions, and then one per session. And in a real world application, that might be dozens to hundreds of HTTP calls. And kind of like the async await that Ken showed you, you get the thing that subscribes to this will have a single error handler that will get the errors if any one of those HTTP calls fails. So that's pretty helpful. So here's the subscribing side. This is the thing that would call that service method. And here you can see calling the method. And okay. So, and then this is not even in the service. This is on the receiving side. You can see we've used the pipe operator, which says we're going to do one or more commands on the observable before we actually consume its result. And here we've put a delay operator in there for 2 seconds to simulate a slow network, just so things don't flash right up on the screen in the demo. And you can, inside that pipe, you can chain as many as you want. It's just comma delimited operators. And there's all sorts of things you can do in there. We just have a simple delay in there. And then we're subscribing to the observable. Observable actually has, subscription actually has 3 callbacks, one for, and it's very similar to the async await. The first 2 are anyway. This is the success callback, and pretty typically for TypeScript, that's an arrow function. You could just name a function here. We're using our arrow function. So this is the components, this pointer. And here we're just assigning it to the components local variable. There's an error handler. Again, if any one of those HTTP calls fails, we'll fall into the error handler here. And there's, as Pete would say, some terrible error handling, because all we did is log it to the console and the user has no idea. And there's a third, and all of these are optional. There's a third one that I don't have here, which is, gets called when the observable completes, when the whole sequence of things that the observable is going to emit is complete. And for HTTP, that's a one-shot, so you always get that after you get either the success or the error handler. It's done immediately as soon as it admits one thing. Okay, so directives. Directives have the directive decorator. They're kind of like components, except that they can affect the view, but they don't have views of their own. And there's structural directives that modify the structure of the DOM. Angular has ngF and ngFor. And I'm going to start rushing through this because Ken tells me I have 5 minutes left. And I have quite a bit of content, so I'm going to run through it pretty quickly. An attribute directive, for instance, could be used to highlight a piece of text. It basically says, if I find a particular directive in your template and I'm in the scope of the dependency injector, I'm going to highlight that text. And right here, we see an ngIf directive. You can tell it's a structural directive because it has an asterisk in front of it, some of the magic syntax. And that says, if I have the schedule, render this template, else render a template named busy, and I have another template called busy that has a spinner or something. You also see the template, the expression binding going on here. And we're actually using pipes here, which we'll get to in a second. And there's a custom attribute directive. It says, if I find, a node that has the app highlight attribute in it, then I'm going to take the element and set its style to a background color of yellow. And this is how you would use it down here. Angular has pipes. Again, this is a custom date pipe that you'll find in our application because we have a sort of a non-standard date format that's not included in the built-in date pipe. So this is a custom date pipe. It's really just a class that has a transform method. And it gets annotated with the pipe, decorated with the pipe decorator. It's got a name called short date. The name is what you use when you refer to the pipe. And here's an example, again, an example that these are the pipe names. I have a couple of different pipes. It's taking a date and piping it through the pipe and then putting that out as a string in a simple template binding. Okay, so that actually we're going to fit it in 5 minutes, I think. So what are the takeaways about Angular? Well, Angular is a full-featured framework. It's batteries included, like I had on the first slide, and like the title of the application said is it's your API overlord. There's an API for that. It's a good fit for development teams who are not heavily attached to pure JavaScript development because of its heavy use of TypeScript. It's a very good fit for development teams that are currently using object-oriented backends. They're familiar with the object-oriented principles. Again, TypeScript looks object-oriented. It compiles the JavaScript, so there's some things to be aware of. But it's a pretty comfortable environment for an object-oriented developer. It's a good fit for medium to large applications. You could certainly develop a small application with Angular, like we did for the presentation today. You're probably not going to see many of the benefits when you're doing a small application, unless you're doing a lot of small applications, in which case its ability to package up Angular-specific libraries and reuse them across applications is a big help. There's a large community with a lot of support, lots of resources online, at conferences. Some of it's actually accurate. If you're doing Angular, you're pretty much going to be doing TypeScript. Your views are in HTML, so I'm not aware of anybody doing anything JSX-like in Angular. There's probably a library for that somewhere, but I'm not aware of it. RxJS is used everywhere, so if you go with Angular, prepare yourself for a bit of a learning curve. You're going to have to learn RxJS. Well, you can do everything with promises, but you probably wouldn't. It's really easy to create libraries from components, services, even large components. A client I'm working for now has a reusable set of largish components, ones that you would actually route to, like a reporting interface and a scheduling interface and things like that. And we package those up, put them in our local NPM repository, and use those across all of our applications. It can be used for both web and native development. And that's all I have. So any questions in the few minutes that we have? Okay, thank you.